we're continuing with sections 2.6 and 3.6, and this is trigonometric limits. We're doing example 3, limit as x approaches 0 of sine of 4x over x. Oh, this looks a little bit like an identity we did before. What was the identity? So the identity is limit as x approaches 0 of sine of x over x is equal to 0. What are the similarities here? I see that I have sine of an angle over a variable over here and over there, except here the angle and the variable are matching. Here the angle is not matching the variable. I cannot change the angle a whole lot because it's sine of 4x, and converting that to an expression of sine of x will require a lot of identities, and then we basically make the limit a little bit more complex. And let's face it, we don't always remember our identities, and we make a lot of mistakes doing those type of things. Plus, the identities may get more and more complex when you make the examples more and more complex. So is there another way? Yes, there's a method that works on most of these limits, and we have to learn it. And so the method involves, I see the argument of sine is 4x, I make the denominator 4x, but that changes the fraction, so I multiply the top also by a 4x. But then that 4 on top is extra, but that's okay, it's just part of the limit, and I deal with it as I go. So we're doing limit as x approaches 0 of sine of 4x over 4x. Now, not bad. And I see if I ignore the 4, if I cover up the 4, I will end up with a very similar expression as that, except that I don't have 4x goes to 0. I have x goes to 0. But wait a minute. If x goes to 0, what does it mean for 4x? If x is going to 0, means and u is equal to 4x, then limit of u as x goes to 0 is equal to 0 as well. So u is going to 0 as well. And so now, set that aside. What do I do with that 4? First, you take the 4 outside the fraction, because then you have the expression that you want and you have the 4. Then you take the 4 outside the limit, because it's possible, it's a constant multiplier, and therefore you can go out of the limit. And so you end up with 4 limit of z, which z is equal to 4x. Limit as z approaches 0, which z is equal to 4x of sine of z over z. But then that limit is exactly 1. This part is exactly that. I'm sorry, this part, no, again. This part is exactly 1. And so the answer is going to be 4. And the answer is 4. Now, example 4, this time we have limit as x approaches -2 of sine of x plus 2 over x squared plus x minus 2. Let's plug in -2. If I plug in -2, I will have the form is going to be 0 over 0. -2 power 2 is 4 minus 2 is 0, and sine of 0 is 0. So what do I do? This doesn't quite look like what I remember, but is there possibility that it looks like this, and I'm just ignoring it. So this is the only identity now I know. And it doesn't quite look like it as I'm looking at it, but maybe it does. There's a sign of x plus 2. What if x plus 2 is a factor of the denominator? Can it be? Yes, it can, because the denominator is a quadratic and it becomes 0 when you plug in x equal to -2. So what do? Factor the denominator, and then when you factor the denominator, x plus 2 appears. Then then separate the two fractions and then separate the limits. So you separate sine of x over x plus 2 over x plus 2 and 1 over x minus 1, and separate the limits. Why can we do that? Because both limits will exist basically, and there are and so we can use the product limit of product law. And so when you do that and put the limits on each of them, the first one is not an indeterminate form. It has a number. If I plug in -2 in here, and direct substitution is the way to go. But the second one, notice if I say set u to be x plus 2, again u is going to go to 0, therefore the second part just becomes that limit of u goes to 0 of sine of u over u. So that's what I'm going to do. So after substitution, this part becomes -1/3, and this part becomes limit as z approaches 0 of sine of z over z, and then that is going to be -1/3. Example 5. Limit as x approaches 0 of 1 minus cosine of 3x over x squared. Oh, this is a little bit different. I don't see that sine of x clearly. But there was this fun method that we used a lot, and that was we actually multiply something by conjugate. What would the conjugate of this be? 1 plus cosine of 3x. So multiply the top and bottom by 1 plus cosine of 3x. Then it makes the top 1 minus cosine squared 3x, and the bottom becomes x squared times 1 plus cosine of 3x. What is 1 minus cosine squared 3x? That's sine squared. This one is sine squared. Sine squared 3x. And so replacing that by sine squared 3x, you get this expression. You get this expression. Now, I have sine squared 3x, and I have x squared times 1 plus cosine of 3x. As x approaches 0, the limit of this is going to be a 0 over 0 again, form 0 over 0. What do? But now I can see there is, if you remember, I have sine of 3x and x in the bottom, and both of them are of degree 2. So maybe I can put each one separately and see how it goes. So that's what we do. First, we put in limit as x approaches 0 of sine of 3x over x, another limit as x approaches 0 of sine 3x over x, that these two together make that limit of sine squared 3x over x squared as x approaches 0. And then keep the 1 over 1 plus cosine 3x separately. And that immediately has a limit. And these two pieces also have limits. And again, you see that we did repeated the story that we repeated in the example 3. We multiplied top and bottom by 3x. And so you're expecting that 3 to get out pretty quickly, the top 3 to get out, because that's not, it doesn't belong there really. It just it has to get out of the limit. It's a constant, and I want the other 3 to be in here because I want that, use that identity. And I use that identity, and the first limit becomes 3 because that's the limit of sine of 3x over 3x as x approaches 0 is going to be 1. The second limit becomes 3 also, and then the last limit, if I substitute, I get 1 over 2. So the answer is 9/2. I got here question 5. Limit as x approaches 0 of 1 minus cosine of 2x over x is a 0, b 2, c 4, d 0.5, e 0.25. So take a moment and think about the problem and answer it and come back. So I know that if I plug in 0, I get form 0 over 0. So what I do is I realize that the only thing that I know at this point is the identity that involves x. But this does not have x. It has cosine of 2x. So what is a person to do? Actually, I have another identity too, and I show you both ways. But in this case, if you only had that identity, you would multiply the top and bottom by the conjugate. Why? Because then it would give you the other identity. And then here you will get limit as x approaches 0 and 1 minus cosine squared 2x divided by x times 1 plus cosine of 2x. And that is, now it's going to be limit x approaches 0 of 1 minus, it would be of sine squared 2x over x 1 plus cosine of 2x. Okay, so I have the terms that makes it 0 are sine of 2x, and the factors that makes top 0 are sine of 2x and bottom is x. But sine of 2x is to power 2, bottom is not. Separate them from each other. And put 1 with the, because you don't have another sine x, put the other one with 1 plus cosine of 2x. And now if I do the trick and do 2 and 2, then this limit becomes 2, but this limit, if I substitute, is going to be 0. So I get 0. Now, it pays off if you remember the other identity that involves cosine. What is that other identity? The other identity is limit of 1 minus cosine of x over x as x approaches 0 is equal to 0. Now, let's go on with that. And then this is, but then, oh, the difference here is that it's cosine of x over x. Here we have cosine of 2x. 1 minus cosine of x over x, and 1 minus cosine of 2x over x. So what do? Do the trick that you did with the identity sine of x over x identity. And that is multiply both top and bottom by 2. 2 comes out of the limit. Two comes out here. Now this part is 0, 0 times 0 gives you 0. So this was a little bit less work. Why? Because when we proved this identity, we actually used the conjugate. So it already has that part done for us.